On the morning of May 20th, 1999, a demolition crew packed explosive charge against a bundle of steel cable, 5 inches thick, 310 feet up in the air. Below them sat the largest machine that had ever walked on the surface of the earth. It weighed 27 million pounds. It had not moved since 1991. 20 miles away, at American Electric Power's offices, negotiators were still on the phone about how to save it. The charge went off anyway. 6 seconds. That's how long the blast lasted. The cable let go, the boom folded at the middle, and 310 feet of American steel came down into the Ohio hillside in a single collapse. Whatever chance there had been to save Big Musky ended in those 6 seconds, while the people trying to save it were still arguing for more time. By the time the dust settled, one thing was certain. America's biggest dragline excavator, 27 million pounds of it, was leaving that hillside as scrap. Trucked out. Melted down, sold by the pound. What's harder to explain is how a machine that took 340 rail cars and 260 trucks just to bring onto the site became too expensive to save and too enormous to move, so that cutting it into pieces small enough to haul away was the only option anyone had left. So how do you actually kill something that size? Not with one blast. Those 6 seconds on May 20th were the moment nobody could take back, but they weren't the whole story. Everything before them, and almost everything after them, moved slower and mattered just as much. 8 years of the machine sitting idle on a hillside, a fundraising campaign that came up short, a scrapping contract signed while people were still trying to stop it, and then 12 straight months of men with cutting torches working their way through 27 million pounds of machine, one section at a time. Here's what isn't in question. For 22 years, this machine did something no other machine on Earth could do. What's still worth answering is why its own size, the thing that made it remarkable, is exactly what made it impossible to save. 27 million pounds. Say that slowly and it still doesn't land, so picture it differently. About 9,000 pickup trucks welded into one machine, then given legs. Central Ohio Coal Company, a mining subsidiary of American Electric Power, signed the contract for it in 1966. Bucyrus Erie engineered and fabricated the components at its plant in South Milwaukee, Wisconsin, then shipped them to a hillside outside Cumberland, Ohio, for assembly on site, since nothing that size could be built anywhere else, and then moved in one piece. It took 340 rail cars and 260 trucks just to haul in the parts. A shipping effort large enough that it would still be the first thing the machine's eventual demolition contractor brought up, 30 years later, when a reporter asked him what his crew was walking into. Putting those parts together took roughly 200,000 man-hours, on top of years of engineering before a single piece shipped. It cost $25 million in 1969 money. The machine was dedicated on May 22nd of that year, in front of the Morgan County High School marching band, photographed standing in formation inside the empty bucket. It was a Bucyrus Erie model 4250W dragline excavator, and it was the only 4250W Bucyrus Erie ever built. 22 stories tall, 151 feet wide, wider than an 8-lane highway laid on its side. A 310-foot boom, about the length of a football field. A bucket that held 220 cubic yards and could scoop up 325 tons of dirt and rock in a single bite, or, as Ohio Department of Natural Resources historian Neil Humphrey put it, about the weight of a Boeing 747. This was a thing that was larger than life in every way, Humphrey said, adding that during its working life, it was simply the biggest moving object on the planet. For 22 years, that's exactly the job it did. Strip the dirt, shale, clay, and sandstone off the top of southeastern Ohio's coal seams so smaller machines underneath it could get at the coal. It ran around the clock, every day of the year except Christmas. Over that stretch, it moved more than 608 million cubic yards of earth, roughly twice the volume excavated to build the entire Panama Canal, and it uncovered more than 20 million tons of coal underneath. Central Ohio Coal built it because post-war demand for electricity had outrun what smaller machines could keep up with, and because a mining property spread across 110,000 acres of Appalachian foothills needed one machine that could do the work of several without multiplying the crews required to run them. At the dedication in May of 1969, the whole community turned out. The Morgan County High School marching band posed in formation inside the empty bucket for a photograph that still passed around the region today. Wendy Waite, later the director of the county's Visitors Bureau, was a kid in that band, standing in the front row. 50 years on, when the school recreated the photograph for an anniversary, she pointed herself out in the original. "That's me," she said. There was a safety argument behind the decision to build something this size too, and it mattered as much as the economics did. Central Ohio Coal was choosing surface mining over sending men underground, and a dragline that never required a single miner to work beneath a roof of rock was measurably safer than the shaft mining methods still common across Appalachia at the time. The mine shaft, and everything that could go wrong inside one, was Big Muskie's real rival, more than any other giant machine ever was. None of that is what tonight is about. Tonight is about what it actually took to make 27 million pounds of American machinery disappear, and why the answer turned out to be so much harder than anyone expected. Big Muskie's size had always been the entire point. In the 1960s, Central Ohio Coal's mining property ran across more than 110,000 acres of hilly ground, and one oversized dragline made more economic sense than a fleet of smaller machines chasing that terrain one hillside at a time. For 2 decades, that math worked. The machine also broke down constantly, because a piece of equipment with no equal has no spare parts shelf either. It worked every day when it wasn't broken down, said Eddie Lindemore, Big Muskie's first supervisor, back when it went into service in 1969. Failures were routine by his account, but the crew kept it running 7 days a week regardless. Christmas was the only day it ever shut down. A standing maintenance crew stayed on hand around the clock just to keep it running, on top of the rotating operating crews the machine needed to work at all. Keeping it running took more than luck. Chasing down cable wear, motor faults, and hydraulic leaks on a machine that size meant climbing several stories of internal ladders and service platforms just to start a repair, since most of what could fail was buried deep inside a 22-story structure and not sitting conveniently on the surface of it. Winters meant de-icing cable by hand before a shift could even begin. Summers meant keeping dust out of motor windings that could overheat if nobody was watching them. None of that showed up in the tonnage figures Central Ohio Coal reported every year. All of it showed up in the maintenance budget, and by the 1980s, that budget was climbing at the same time coal prices weren't. Then the math stopped working. The 1990 Clean Air Act amendments tightened sulfur dioxide limits at power plants, and Ohio's coal seams ran high in sulfur, so utilities that had bought that coal for decades started buying cleaner coal out west instead. Electricity itself wasn't cheap either. Running Big Musky meant drawing power equivalent to 27,500 homes, at a cost of tens of thousands of dollars an hour, before a single dollar went toward keeping a 22-story machine from falling apart. Decades of stripping had also worked through the shallow coal within Big Muskie's reach, leaving thinner seams a machine built for shallow, high-volume digging wasn't suited to chase efficiently. No single one of those forces killed Big Muskie on its own. Together, they made it a machine nobody could justify running anymore. In 1991, Central Ohio Coal shut the dragline down. By then, the easy coal was gone anyway. Big Muskie had been built to strip the Meigs Creek No. 9 seam, and after more than 2 decades of stripping, what remained of that seam within the machine's reach sat thinner and deeper than the shallow, high-volume ground the 4250W was designed around. A machine engineered to move enormous volumes fast doesn't get more efficient chasing a shrinking, awkward seam. It gets less efficient, at exactly the moment its operating costs were already climbing. The company tried to find it another life first. Nobody wanted it. Selling Big Musky to another coal operator meant paying to take it apart, ship it, and reassemble it somewhere else. And by 1991, no American strip mine still ran equipment on that scale. Overseas, only Germany's brown coal pits could have used a machine that size, and Germany already had its own giant excavators, ones that moved more material on less power. There was, in the end, no buyer anywhere on the planet, so it sat. For 8 years, 27 million pounds of dragline stood parked on a hillside outside Cumberland, doing nothing, while a federal law caught up with it. The Surface Mining Control and Reclamation Act required that land taken out of production be restored to something close to its original contour, equipment included, and that meant Big Musky's own hillside, the one it had spent 2 decades reshaping, now had to be handed back looking untouched. A 22-story machine standing in the middle of an active reclamation site wasn't a detail the state of Ohio and the federal government were willing to overlook, and every year it stood there ran the company closer to fines nobody wanted to pay. Restarting it was never a real option either, the longer it sat. A custom, one-of-one machine built around 1960s parts doesn't idle gracefully for 8 years. Components would have needed sourcing from a manufacturer whose own product line had moved on. Control systems would have needed recertifying. Coal prices, meanwhile, had kept falling in the years Big Musky sat still, so the economics that had already ended its working life in 1991 were worse, not better, by the time anyone might have considered firing it back up. Every year of silence made every other option, sell it, move it, restart it, more expensive than it had been the year before. The very thing that had made Big Musky worth building in the first place, that there was nothing else like it, was now the reason nobody could figure out what to do with it. When Central Ohio Coal parked Big Musky in 1991, nobody was ready to say goodbye to it. Nobody knew quite what to do with something that size, Neil Humphrey would say later. Some people wanted a museum, some wanted to take pieces of it and put them somewhere else, scattered rather than gone entirely. A local nonprofit called the Byesville Community Development Corporation picked up the museum idea and ran with it, launching a campaign that came to be known simply as Save Big Musky. The pitch was straightforward: keep the dragline where it stood, or somewhere close to it, and turn it into a museum and tourist draw, the way Big Musky's old rival out in Kansas already had. That machine, a stripping shovel called Big Brutus, had been saved by a comparable local effort back in the 1980s and was pulling in tens of thousands of visitors a year by the time Big Musky's own campaign got started. Organizers argued the same thing could happen in Ohio and projected well over 100,000 annual visitors if the dragline could be preserved next to its new neighbor, a wildlife park called The Wilds, built on land Big Musky itself had mined and helped reclaim. The campaign collected tax-deductible pledges for months. Money came in, so did promises of more, including support pledged by the Wilds itself, which stood to gain from any tourist traffic a preserved muskie would bring next door. For a stretch, it looked like Big Musky might join the short list of retired industrial giants that get to keep existing after their working life ends. The vision organizers were selling was specific: walkways built around the machine's base, an information center inside the old machinery house, guided tours through the operator's cab where Eddie Lindemore and men like him had once worked. Something similar had already happened with Big Brutus, the stripping shovel that had done comparable work at a mine in southeastern Kansas. When that machine's owners walked away from it in the early 1980s, a local push led by the surrounding community took ownership of it, incorporated a non-profit around it, and built exactly the kind of roadside attraction Save Big Musky was now proposing for Ohio. Big Brutus worked as a case study precisely because it proved a retired mining giant could pay for its own upkeep through admission tickets and gift shop sales, once somebody covered the cost of stopping it from rusting into the ground in the meantime. Big Musky's organizers pointed to that example constantly. What they couldn't point to was Big Brutus's biggest advantage: a shovel that had simply stopped digging, Sitting on land its owner no longer had any legal obligation to restore. Big Musky sat on land under an active, federally enforced reclamation deadline, owned by a company that stood to be fined for every year the machine kept standing there unreclaimed. The two machines looked alike in outline. They were nothing alike in the paperwork attached to them, and the paperwork is what decided which one survived. The reclamation clock didn't pause for fundraising either. Every month Save Big Musky spent building support was a month AEP's own deadline kept moving closer, and the two clocks were never running at the same speed. It wasn't enough. Whatever combination of pledges and cash the campaign managed to raise fell well short of what full preservation would have cost. Buying the machine outright from AEP and stabilizing 27 million pounds of aging steel against the weather, indefinitely, on ground the state still expected handed back looking untouched. Exactly how much the campaign collected in the end isn't part of any public figure that survives today. What survives instead is simpler and just as telling. However much it wasn't enough to beat the deadline. AEP wasn't hiding from the preservation talks either. Even after the company put Big Musky's demolition out to contract, negotiations with preservation advocates continued in parallel. Sit with that for a second. The scrapping contract had already been signed, and salvage crews had already started cutting into the machine's smaller components, while AEP was still on the phone, at the same time, about whether some version of Big Musky could survive. Moving it whole was never seriously on the table either. A machine that took 340 rail cars and 260 trucks to bring onto the site in pieces would have needed a comparable effort to remove it, with no realistic buyer, museum, or park anywhere able to absorb that cost on the other end. The only way Big Musky left that hillside intact was if someone found the money to let it stay exactly where it was. Nobody did. In January of 1999, AEP signed a contract with Mayor Pollock Steel Corporation of Pottstown, Pennsylvania, to dismantle Big Musky and dispose of it as scrap. The site closed to the public that March. And still, the phone calls didn't stop. For a few more weeks, that was the strange shape of Big Musky's ending, crews on site starting to cut, and people off-site still trying to talk them out of it. Taking apart something built to survive 22 years of digging started, of all things, with paperwork, and then with 15 men. Before Mayor Pollock's crew ever set foot on the hillside, AEP finished its own environmental preparation on the machine, draining decades of hydraulic and lubricating fluid out of its systems and clearing away anything the state would classify as hazardous material, the unglamorous groundwork that has to happen before anyone's legally cleared to start cutting apart industrial equipment on that scale. Only after that was complete, in March of 1999, did Mayor Pollock actually move in. 15 men, mobile shear cranes, crawler cranes, and track loaders arriving to take apart the largest thing any of them had ever been hired to scrap. 15 men against 27 million pounds. Mickey Pollock, the company's president, had already done the math on what his crew was walking into. "It's a big job," he said, citing the same railcar and truck count that had once hauled the machine's parts onto the site as reason enough not to expect a quick finish. He was right. The job would run roughly 12 months, start to finish. The first weeks weren't dramatic. Crews worked their way into the machine's interior, stripping out smaller components, cabling, and equipment that could be pulled without touching the structure, still holding the rest of it up. It was slow, methodical work, and it ran for weeks while, a few miles away, the phones between AEP and Big Musky's preservation advocates were still ringing. What those first weeks actually removed was the machine's nervous system, cable runs, control panels, smaller motors, anything that could be unbolted without threatening the structure's overall balance. Big Musky's interior held its own kind of maze, service platforms and internal ladders connecting a machinery house full of switchgear to an operator's cab several stories up, all of it built so a small maintenance crew could reach any part of a 22-story machine without waiting on a crane. Salvage crews used those same internal walkways the machine's own mechanics had used for 30 years, just in reverse, not fixing what they found, pulling it out, A typical day on site that spring ran the way most industrial demolition does. Nothing that would make a highlight reel, just 15 men working through a checklist of cuts, one bolt pattern and one cable run at a time. The work order didn't care that the machine had a name. It cared about sequence, about what could safely come out next, and what had to stay in place until whatever was above or below it came out first. Then came the boom. At 310 feet, Big Muskie's boom was the single most dangerous piece of the machine to leave standing during a teardown. It hung out over the demolition site like a loaded crane nobody could safely work underneath, suspended by cable 5 inches thick. Taking it down wasn't optional. The only real question was how. Lowering a boom that size with cranes alone would have meant finding equipment capable of controlling 310 feet of falling steel on the way down, on a hillside site with no room for machinery on that scale. Explosives solved a problem cranes couldn't. They let the crew choose exactly where and when the boom failed, rather than guessing how long overstressed cable would hold once the cutting into the surrounding structure had already begun. It was, in its own way, the safer option for the single most dangerous part of the job. Mayor Pollock's answer, in the end, was explosives. Preparation for the boom went on for days beforehand, crews rigging charges against those 5-inch cables, clearing the ground below, running through the sequence one more time. Word that the boom was finally coming down spread through the county fast, and a safety perimeter went up around the base of the structure well in advance, keeping the small crowd that gathered a clear distance back from where 310 feet of falling steel would land. There was still, even then, no formal word that the preservation talks were dead. AEP and the machine's advocates were still negotiating when the contractor made the call to proceed anyway. That was the point of no return, the decision nobody could walk back once the charges were set. On the morning of May 20th, the crew cleared the site and triggered the charges. What happened next took 6 seconds. The cables let go first, all at once, and for a moment, the boom simply hung there with nothing left holding it up. Then it folded at its midpoint and came down, raising a wall of dust that took longer to settle than the collapse itself had taken to happen, watched by a small crowd that included some of the region's own former Muskie crews who had come out to see it happen in person. For a few days afterward, the hillside sat quiet. What had been the single largest moving object on the planet was now a beheaded hulk of structural steel with a twisted ruin of boom lying beside it, and the real work of turning the rest of it into scrap hadn't fully started yet. Big Musky had gone up from the ground first, base and walking gear ahead of superstructure, over roughly 2 years in the late 1960s. It came down in something close to the opposite order, the highest, most exposed structure first, then everything underneath it, section by section, for the rest of 1999. Picture standing at the tree line above the pit that summer, watching the site change week over week. One month there's a machinery house full of cable and switchgear where the DC motors used to live. The next month there's a bare steel frame. The month after that there's a gap in the skyline where a wall of that frame used to be. Nothing about the process looked like an explosion twice. Mostly it looked like a slow subtraction, repeated for months, until there was less machine every time you looked than there'd been the week before. Locals still driving past on the county road noticed the same thing from a distance. A skyline that had stood unchanged since 1969, quietly losing pieces of itself, month over month, until the shape everyone in the county had grown up recognizing from 2 miles off stopped being recognizable at all. Crawler cranes lifted the sections too large to move any other way. Cutting torches sliced through steel plate too thick for shears alone to handle. Mobile shears reduced smaller structural members down to pieces that would actually fit on a truck bed. None of it moved fast. A machine engineered to survive decades of cyclical stress didn't come apart in an afternoon, or a week, or even a season. The same 18,000 horsepower and 10 625 horsepower DC motors that had once swung a 220 cubic yard bucket got trucked off as components or reduced to scrap alongside everything else. The 5-inch cable that had held up a 310-foot boom got cut into sections and hauled away as wire rope. Steel plate engineered to withstand 2 decades of hoisting, swinging, and dumping got fed, piece by piece, into a process that treated it exactly like any other steel, weighed, graded, and priced by the ton. By late summer, crews had worked down through the machinery house to the tub, the massive base structure that had let Big Muskie's entire superstructure rotate through each swing of the boom, and to the walking shoes themselves, the pair of oversized steel feet that had once let the machine creep across the mine floor at 1/10 of a mile an hour, one 12-foot step at a time. Those shoes alone were pieces heavy enough to need crawler cranes working in tandem, lifted and set onto flatbed trailers built for oversized industrial loads, then hauled out along the same county roads the machine's original components had traveled in on, 30 years earlier, running the other direction this time. Whatever was too large even for that got reduced further on site first. Nothing left that hillside in a piece bigger than a truck could legally carry. The undercarriage came apart the same way. Crawler assemblies and the heavy steel skids the walking shoes had ridden on, each needing the same tandem crane lifts as the shoes above them. Even the machine's power connection had to be undone. Big Muskie's dedicated substation and the heavy trailing cable that had once snaked out behind the machine carrying 13,800 volts wherever it walked, came down and came out too. One more piece of infrastructure built for exactly one customer that now had no customer left to serve. There's no detailed public record of exactly which month each remaining section came down, only the beginning and the end, the boom in May of 1999 and the finished job roughly a year after. What's certain is that the middle stretch, the machinery house, the tub, the crawlers, the frame, took every bit as long as the boom had taken seconds, with nothing dramatic enough about any single week of it to make the news the way May 20th had. By the time the crew made its last cut, there was no ceremony to it. Nobody photographed the final piece of steel coming off that hillside the way they'd photographed the boom coming down, or the way the marching band had once posed inside the bucket at the very beginning. The job simply ran out of machine to cut, closed out with nothing more than a final invoice, except for the one piece nobody had touched. Every few days through that year and into the next, another convoy left the site the same way the machine's original parts had arrived 3 decades earlier. Flatbed trucks queued along the county road, loaded now instead of arriving empty, headed for scrap processors instead of an assembly yard. Unlike assembly, scrap doesn't have to leave in any particular order. It only has to leave weighed and priced. The job wasn't finished by the time the leaves turned that fall or by the time snow came. Cutting steel outdoors in an Ohio winter is its own kind of slow. Cold metal fights a torch harder than warm metal does. Ice turns every platform and ladder rung into one more hazard to check before a boot goes on it. And daylight runs out by mid-afternoon in December, shortening the usable hours in every shift. None of that shows up in a demolition contract's original schedule. All of it shows up in why a job initially pegged at roughly 12 months ran through a second Ohio winter before it was done. The crew working a 22-story machine down to nothing across 2 changes of season, because a job that took 200,000 hours to build doesn't reasonably come apart in a single summer, whatever a headline promises. Cutting into an aging 22-story structure that still carried suspended loads and standing height at every turn is not, by any reasonable measure, safe work. Every cut risked shifting a load nobody could fully predict the balance of. Every torch pass near an old hydraulic line risked igniting fluid that had sat trapped in the machine's joints for 8 idle years. Every ladder climb ran 3 or 4 stories higher than most construction work ever asks of anyone. They spent the better part of a year doing all of it anyway. By every account of the job that survives, the teardown went off without a reported injury, a detail easy to skip past and worth pausing on. The most dangerous stretch of Big Muskie's entire existence may have been the one nobody got hurt during. Here's the number worth holding on to for what's still ahead. By the time Mayor Pollock's crew finished, the site had produced more than 15,000 tons of scrap steel by the trade press's own estimate at the time. Whatever that number turns into once it's converted to dollars is coming. Everything Big Musky was made of had to be cut down to a size a highway would allow. Even the biggest single-bucket digging machine on Earth, in the end, got reduced to the same units as a wrecked car: tons, trucks, and a bill of sale. The men cutting Big Musky apart in 1999 were mostly strangers to it, a demolition crew brought in from Pennsylvania who'd never seen the machine run and had no history with the region beyond the job in front of them. Used to scrapping ordinary industrial equipment, they now found themselves inside something that dwarfed anything else on their resume, working a hillside 300 miles from their own shop, boarding locally for the better part of a year to finish it. The men who'd built Big Musky and run it for 22 years were not strangers at all. Big Musky never employed more than about 50 people at a time, split across 4 rotating crews, with each shift built around 2 operators, an engineer, a mechanic, and several standbys. Running the controls well took years to learn, not weeks. An operator worked hoist, drag, swing, and walk controls at the same time, judging the bucket's position mostly by feel and sound rather than by a clean sightline, since much of any given cut was happening far below the cab and out of direct view. A miscalculated swing could put 325 tons of material somewhere it wasn't supposed to go, or put that same weight through a support the machine wasn't braced to take it on. Central Ohio Coal didn't rotate people through that seat casually, and the same names tended to stay attached to the same shifts for years. One of the mechanics who kept the machine running that whole time, according to his daughter Shannon Markin, spent a total of 7 years on it, 50 hours a week, 51 weeks a year. He knew every bolt and line on it, she said. That kind of closeness produced its own stories that had nothing to do with coal at all. One Christmas Eve, he was called out around 8 at night to fix a hydraulic line, brought his 2 kids along, and found the crew had strung Christmas lights across the boom and bucket and brought their own children out too. Each kid got a turn in the cab, feeling the machine take a few steps just for them, before a man dressed as Santa Claus rode down inside the lowered bucket with a bag of gifts. That's the same bucket sitting in a park in McConnellsville today. In 1999, it was still attached to a working part of somebody's life. That mechanic was there on May 20th, one of the former crew members who came out to watch the boom come down. That day, according to his daughter Shannon, was one of the only times in her life she ever saw a tear in my father's eye. He'd been promoted off Big Musky 9 months before the 1991 shutdown, but he came back for this. He worked another 2 decades in the region before he passed away in 2015. Still talking, his daughter said, about the guys he'd worked with and the machine he'd known every bolt of. Grief for Big Musky wasn't limited to the men who'd operated it. Southeastern Ohio, more broadly, had treated the machine as a regional landmark for 2 decades. Photographed on postcards, toured by visitors, even after it stopped running. When word got around that it was finally being cut apart for scrap, plenty of people who'd never worked a single shift on it were sorry to see it go. Word of what was happening on that hillside moved through the region the way word moves through any small place built around one major employer, fast and personally. Central Ohio coal families traded photographs and updates the same way they'd once traded shift schedules. Men who'd left the company years before for other work still drove out that spring and summer just to watch from the county road, the way you'd check in on a relative in failing health, whether or not there was anything left to do about it. Not every memory attached to Big Musky is a fond one. A woman named Martha Bradley Maxwell drove up from Texas a few years back to see the machine's remains in person, to stand near where her cousin, Charles Mitchell, had once worked. Mitchell died on the job at Big Musky at the age of 26. Seeing the bucket for the first time, Maxwell has said, was the moment the scale of what he'd actually worked on finally became real to her in a way that hearing about it secondhand never had. Add it up, and the arithmetic is almost cruel in its simplicity. It took roughly 200,000 man-hours to build Big Musky into a machine anyone could recognize by name. It took a crew of 15 men about 12 months to turn it back into something no one could tell apart from any other pile of scrap steel. More than 15,000 tons of it, by the trade press's estimate at the time. Central Ohio Coal sold the rights to essentially all of that steel, plate, cable, motor housings, structural framework, everything but one component, to Mayor Pollock for $700,000. $25 million to build, in 1969 money. $700,000 to sell what remained of it 30 years later. Even leaving inflation out of it entirely, that gap is the whole story in two numbers. What happens to a machine once nobody wants it to keep existing as itself, only as raw material for something else? For Mayor Pollock, a national demolition and scrap processing firm, even before it took this job on, Big Musky was an enormous contract, but not a strange one. Reducing outsized industrial equipment to sellable steel was the company's ordinary business. The Muskingum County hillside was, in the end, simply the largest single job the company had ever been sent out to finish. Where that steel went after it left the hillside, the public record doesn't say in any detail. Presumably it went where structural scrap usually goes, melted down, reformed, and poured into the next generation of buildings, beams, or rebar, with nothing left on any of it to say it had once been the largest dragline excavator ever built. That's the part that's easy to miss about scrapping something this size. It doesn't get destroyed so much as unmade, broken down past the point where it's still identifiable as anything in particular, and turned into material for somebody else's project instead. Somewhere in that 12 months, a crew with cutting torches reached the operator's cab, the one enclosed room on the entire machine built for a single person to sit in, the room every hoist, drag, swing, and walk command had passed through for 22 years on its way to the rest of the structure. Nothing about the cab made it structurally harder to remove than any other section. It came apart the same way everything else did, cut into sections, lifted clear, weighed with the rest of the load. There's no record of anyone marking the moment as different from any other cut that month. By the ledgers Mayor Pollock was keeping, it wasn't. Only one piece of Big Musky ever escaped that fate, the bucket. 220 cubic yards, roughly 240 tons of empty steel, big enough that an entire high school marching band once stood inside it for a photograph at the machine's 1969 dedication. It was set apart from the rest of the demolition early on, the one component AEP had decided from the start was worth keeping whole. It didn't even leave right away. The bucket sat on the reclaimed hillside for another 2 years after the rest of the machine was gone, until 2001, when it was finally trucked to a new site and installed as the centerpiece of what's now called Miners Memorial Park. There was some talk, at the time, of saving the whole machine as a museum piece, according to Ronald Mingus, an Ohio Department of Natural Resources park manager. That didn't happen. What did happen, in his words, was that the bucket was saved and moved here in 2001, and Miners Memorial Park was created. There's technically one more surviving fragment, though it never went through the 1999 scrapping at all. Years earlier, when AEP upgraded the machine's operator controls, the original seat and foot pedal swing gear were removed and set aside. They sat in storage for close to 2 decades before eventually being donated to the Bucyrus Museum in Bucyrus, Ohio, where volunteers built an entire replica control console around that one surviving seat, researching old photographs and sourcing period-correct parts to recreate everything else that hadn't survived. Even the one other fragment of Big Musky still in existence needed to be mostly rebuilt before anyone could sit behind it again. The bucket doesn't need rebuilding. It's the genuine article, sitting exactly where it was set down, drawing something like 8,000 visitors a year up a winding stretch of Ohio Route 78, most of whom step inside, take a photograph, and move on. The hillside itself did need rebuilding, and by most measures, it got it. The pit Big Musky had spent decades cutting into is graded, planted, and folded into the 50,000-acre reclamation project, now called Recreation Land, including the ground beneath the wilds, the same wildlife park that had once pledged money toward saving the machine that helped create the land it now sits on. Rhinos and giraffes graze there today on ground that used to be stripped for high-sulfur coal. Judged purely as a reclamation project, the site did exactly what the Surface Mining Control and Reclamation Act was written to make happen. Judged as a piece of American industrial history, what's left standing on all that reclaimed acreage is one bucket and a sign. None of that 50,000 acres ever needed Big Musky itself to still be standing on it. That turned out to be the whole problem the preservation campaign could never get around. The land recovered fine without the machine. Only the machine's own memory needed saving, and memory doesn't show up on a reclamation bond. In June of 2025, the state added a historical marker beside the bucket, formally putting Big Musky's story into the record the way the machine itself never got the chance to stay in the ground long enough to earn. Big Musky wasn't just a machine, it was a symbol of American industry, ambition, Audner director Mary Mertz said at the unveiling, framing the marker as recognition of both the ingenuity that built the machine and the environmental standards that eventually ended it. Neil Humphrey, the state historian who helped get that marker approved, has argued that without somebody caring enough to remember a thing, it simply disappears. He's said as much about Big Musky directly. This bucket is the only part of the machine left, and if something this size can vanish from history almost entirely, it's worth wondering what else might be next. That's the answer to the harder question in the end. Destroying Big Musky took one company, one contractor, 15 men, and about a year. Saving it would have taken new owners, a new legal use for the ground underneath it, a state willing to look past its own reclamation law, and enough donated money to keep 27 million pounds of idle steel from rusting for decades, all arranged before a federal deadline that never once slowed down to wait for it. Wrecking something that size only ever needed permission from one company. Keeping it needed permission from almost everyone, all at once, before the clock ran out. 27 million pounds went into Big Musky. All but one piece of it came back out of that hillside as scrap, cut, weighed, sold, and scattered into other things. What's left to stand in for the rest of it is one steel bucket, big enough to walk into and stand up straight inside, small enough to fit inside a single roadside park in Morgan County. Everything else you'd need to understand just how large the rest of it really was, you have to take on faith, or work out for yourself, standing inside the one piece that survived.